In this example session, we are again going to discuss few more example about the PCM. So this is example. In this example, 12-bit ADC with analog input voltage ranging from -2 to 2 volt. You need to calculate number of quantization level, step size, quantization level when input voltage is 1.33 volt, quantization error, dynamic range, and SNR of quantization. So, what are given number of bits n and the range of the xm and x max to x min. So this is x min and this is x max. The first is you need to calculate the quantization level. For quantization level, you need to have a n because we know the formula for the quantization level. L is equals to 2 raised to the power n, and we know n is given, which is 12. So for that, you can calculate L is equals to 2 raised to the power 12. So using calculator, so you can calculate 2 raised to the power 12, which is equals to 4096 samples. Second question was to calculate step size. So for the step size, we know that delta is equals to x max minus x min divided by L. So x max is and x min is also given. X max is plus 2 and x min is minus 2. So you using that values x 2 minus 2, and we know already L, which is 4096. So minus and minus plus, so it is 4 divided by 4096, and then you have to write the whole value like 0.009765 because it is required. You do not need to round off, you need to write the complete value. The third question was you need to calculate the quantization level when input voltage is 1.33 volt. Okay, so for that, x is given, x is 1.33 volt, and again you need to calculate the quantization level xq, and we have already calculated or derived the formula of xq in our previous session. That is equals to x min plus delta and then I index. So in this formula, x min is also given, delta we have already calculated, but we need to calculate I, that is index. So index is equals to round of x minus x min divided by delta. So you know x min is also given, that is minus 2, and x is also given, that is 1.33 volt. So 1.33 minus minus 2 divided by the delta, which is 0.0009765625. So that is equals to round off. So if you simplify this inner values, then you can get the value 3409.92. So if you round off this, so you can round off it 3410, because after point you can see it is 92, so it is bigger than 5. So that is why you have to increase this value by 1. That is why you can see it is 3410. So use this value in this equation A, then you can easily calculate the quantization level x min, that is minus 2, and then plus this value, that is the delta multiplied by the index 3410, and then you can see it is 1.3300782125. The fourth question was quantization error, and we know the quantization error is equals to sampled output minus sampled signal. So error is always positive, so it is the difference between the two value, that is the actual value and the output value. So xq we have calculated here, xq is this one, and x that is also given, that is 1.33. So if you take the difference between these two value, so you will ended up with this point 4 times 0 78125. Fifth was to calculate the dynamic range, and we have already calculated the formula or derived formula of dynamic range in our previous session. That is equals to 6.02 n, and we know n is the number of bit that is given, so which is 12. So if you insert that value here, you will end up 72.24 dB. The last one was you need to calculate SNR. So SNR in dB is also derived in our previous session, that is 6.02 n plus 1.76, and if you insert the value of n, that is 12, so you will end up it is 74 dB. So this was a like very good question and a very good understanding. But for an exercise, if I want to change few values and ask you to solve the question as an exercise and write your answer in the comment box, and then I will check if the answer are correct or not. Like if you change the 12 bit with 10 bit and you change the range, like x min is 0 and x max is 3 volt, and similarly the input voltage is 1.2 volt. If you do these changes in the example and then solve for all the determination for all the questions, and you need to know what are the answers. So take it as an exercise and solve this question with these new values and write your answer in the comment box, and I will see if the answers are correct or not. So if the answers are correct, then I will give you input. If the answers are not correct, then I will also give you the input. Now come to another example of PCM. So other example of PCM, the other is like this one. A PCM system uses a uniform quantizer followed by a 6-bit encoder. So n is given 6 bit. The bit rate of the system, so bit rate is also given, that is 50 megabit per second. So what is required? Identify the message bandwidth. You need to calculate the message bandwidth. So for the message bandwidth, you know bit rate is required and n is also required. So bandwidth for which the system represent satisfactorily. Second question was determine the output SNR when a sinusoidal signal of 1 megahertz frequency is applied as the output. So you need to calculate SNR for a given bandwidth of 1 megahertz. So if n is 6, so the bit rate is 50 megabit per second, and we know the sampling frequency is equals to bit rate divided by n. So and the required is the bandwidth required at the bandwidth, which is equals to fs by 2. So fs is equals to bit rate by 2. If you use that formula here, so you can write bit rate by n divided by 2. So bit rate is 50 divided by n is 6, so divided by 2. So if you simplify this, you will end up with 4.166 megahertz because your bit rate is in mega. Second question was output SNR, and we know the formula of the output SNR, that is equals to 1. You can write 1.76 plus 6.02 n, or in some books this is also given 1.8 plus 6n. So you can use this formula as well, no problem. So 1.8 plus 6 and n is also given 6. So 6 6 is the 36 plus 1.8, the answer is 37.8 bit. So let's consider another example. So of the PCM. So that example is a compact disc CD record audio signal digitally by using PCM. Assume the audio signal has 15 kilohertz frequency. So frequency is given. So you need to calculate the Nyquist rate. So we know that the Nyquist rate is dependent on the signal frequency. So if the Nyquist samples are quantized into this level, so L is given, then you need to identify the number of binary digits. So you need to calculate N. So if L is given, you can easily calculate N. The third one, you need to determine the signaling rate, that is bit rate. For a practical reason, the signal are sampled at a rate above Nyquist rate, that is 40100 samples per second. So if L is 16384, determine the number of bit per second received to encode the signal. Also find the transmission bandwidth of encoded signal. All the information is given. First question was that we need to calculate the Nyquist rate. So that is equals to Fs, which is twice the bandwidth. So W is 15 kilohertz. You multiplied by 2. The answer is 30 kilohertz. Second was L was given, and then you need to calculate N. You can use this formula. N is equals to log 2 L. So L is given. So if you simplify this term using your calculator, the answer is 14 bits. Third one was signaling rate, so that is bit rate, and we know the bit rate, it is equals to the number of bits multiplied by the sampling rate. The sampling rate we have already calculated 30 kilohertz, and the number of bits that we have calculated 14 bits. So 14 multiplied by 30, the answer is 420 kilobit per second. The fourth one is that you need to calculate the transmission bandwidth. So if the sampling rate is 4010 samples per second and L is 16384, so you know that you can easily calculate N that we have also calculated above, that is 14 bits. So 14 bit, so Fs is equals to 2 multiplied by W. So from here you can calculate W. So W is equals to Fs by 2 because Fs is given. So that is equals to 20050 hertz. So the bandwidth is equals to N multiplied by W. So now we know N is equals to 14 and W is equals to 20050. So 14 20050. So if you simplify this, you can get this answer 280.7 kilohertz. So that's all. So we still have few more examples, and we will solve those example in our next session. We are closing this session now, and you need to keep in contact so that you can have a few more example in our next section. Thank you for watching the video.